Alright, let's look at the homework 11.9, problem number 10. Alright, starting with the geometric series, we want to find the sum of the following. Alright, so let's do that. Alright, so we're going to start with summation. Oh, actually, this is black there. Alright, I want to use blue. Alright, so you have a summation. N goes from 0 to infinity. X to the n, right? This was just a 1 over 1 minus x, right? So if you take the derivative of this guy, we're going to get what we want. So if you take the derivative of that, so it's a summation, n goes from 0 to infinity. So power rule, put the n in front, x to the n minus 1, right? And since when n equals 0, this term is equal to 0 anyway, so we're going to actually start from 1. So we can change that too. So here it's going to be 1. All right. Then if you take the derivative of the right-hand side, all right, so it's 1 minus x to the negative 1 power, so it's going to be negative 1 over quantity x 1 minus x to the negative 2 power, so it's going to be square on the bottom, then multiply by negative 1, so that's going to be plus here. All right, so I'm going to just erase that. All right, so we found the function whose power series is exactly that. So we have 1 over quantity 1 minus x squared. All right. So let's type it in just to make sure. So we got the 1 over 1 minus x squared. All right, so let's check the answer. All right, we got this one correctly. All right, then if you want to find the following, all right, so let's compare these two. Only difference is this is just the x to the nth power instead of n minus 1. So you just have to multiply by x. So you take the previous result, multiply by x. So it's going to be x over 1 minus x squared. All right? And here, if you want to find this guy, all right, and the only difference between 1 and 2 would be, instead of x, this was, you put the 1/3 plugged in. So we just have to put the 1/3 in there. So it's going to be 1/3, right? And then divide by, and quantity 1 minus 1/3, and squared, right? We can probably simplify that. Maybe it'll take it. All right, so I'm going to just submit for testing. All right, looks like we got this one correctly as well. All right, so it's going to move down here. All right, so for part C, looks like we just need to take another derivative maybe. All right, so let's do that. All right, then if you take another derivative of this guy, so we take the derivative. All right, so we took the derivative there, and we do it again. All right, so this is going to be a summation. N approaches, it goes from 1 to infinity. Right, n was already there, and then we put the n minus 1 using the power rule, and then you have n minus 2. All right, and then derivative of this guy is going to be negative 2 over and 1 minus x to the negative 3 power, so it's a 3 power. Then multiply by derivative inside, so it's going to be positive. So it's going to be, I'm going to just go ahead and erase it. So that's the derivative. All right, then that looks like we need x squared there. So we multiply this guy by x squared. And that way, so this is going to be a summation. All right, when n equals 1, this is 0 anyway, so we can start from 2 without changing anything. Then you have n minus 1. Then this is going to be x to the n because of the x squared there. So you have 2x squared over 1 minus x cubed. All right, so that goes in here. So 2x squared over 1 minus x cubed. All right, so let's type it in. All right, this guy, all right, 2x squared and over 1 minus x cubed. All right, so let's submit for testing. All right, looks like we got the part C number 1 correctly. All right, so let's do part C number 2. All right, so it looks like you have n squared minus n. So we just have to plug in 1 over 5 for x in number 1. All right, so I can probably do it here. So it's a 2 times, and you have 1 over 5, and then squared. All right, then divided by 1 minus 1 over 5 raised to the 3rd power. All right, so let's check the answer. Submit for testing. All right, we got this one correctly here. All right, then the last one, part C number 3, we want to get the n squared over 2 to the n. All right, so we have to do some combination here. So if you plug in here, if you plug in 1/2 there, you're going to get a summation. All right, n goes from 2 to infinity. All right, then you have n squared minus n, and put 1/2, so 2 to the n. All right, so we can get that. But we need to get that guy. So if you need to get number 3, we need to add summation. N goes from 1 to infinity. And then you have an n over 2 to the n. All right. So in order to get that, we're gonna have to actually, since this is from 1, we can actually change it to 1, because when n equals 1, it's 0 anyway. So I'm going to go back and put 1 in there just to be consistent with the problem here. All right. So summation, n goes from 1 to infinity. N squared over 2 to the n is equal to the combination of those two. All right. So this one, all you have to do is take this formula and plug in x equals 1/2. So this is going to be 2 times 1/2 squared over 1 minus 1/2 cubed. All right. Plus. All right, this one, we have a formula here. So n, you just have to plug in 1/2 into here. So it's going to be 1/2 over and 1 minus 1/2 squared. All right. So let's simplify. So you have 2 and one of them cancel out. So you have a 1/2 there. So you have, let's see, so 1/2, and then you're going to have 1/2 cubed. So you can actually cancel this guy, and then this is going to be squared. All right. So this is going to be a 1/2 square on the bottom. So it's going to be 1/4. Reciprocal would be 4. And plus, all right, so it's 1/2 there, and cancel with one of the 1/2. This is 1/2. So it's going to be just 2. So this is going to be just 6. All right, so let's type it in. So this is actually just 6. All right, let's check the answer. All right, looks like we got the last one correctly as well. All right, that's it. I hope that this was clear.